You can also, have workloads run over inside of Compute Engine. I'll show you a demo that uses Google App Engine as the front end for hosting like the website and kind of the interaction of the data model with Compute Engine, where we're doing some scalable computation. We have some other things that are coming. I discovered that there is this thing out there called Google Endpoints. It's in trusted tester mode. Like I thought it was safe to put it on this slide because I typed this in and it showed up on Google, so it must be okay. That's the engineering perspective, by the way. But this is where we're trying to make it easier for you to develop services. So we give you this API layer that handles things like authorization and authentication and payments, and allows like mobile phones and end browsers to send requests in your service. You handle the request, and you send back a response. And so if you've used Google Maps APIs or these other APIs, they are actually this type of Google Endpoints layer that we use internally, and now we're going to offer that externally. And then moving up the stack into the software as a service tier, we have Google BigQuery, and this is our service where you can upload terabytes of data, run a SQL query, and the answer will come back in seconds. The first time you do this, it's actually quite astonishing. I grew up building like SQL Server technology and things like that in years past, and databases could never do this. I was astonished the first time I did it. And then, most people are probably familiar with things like Translate. If you build front-end web pages and you want to get a Google assessment on the performance of your page and how to optimize it, we have services like Google PageSpeed you can actually go use. We have a set of sort of artificial brain models. Anybody see that we took like 10,000 CPUs, went out and trained it on every video on YouTube, and what did it learn to do? Anybody know? Yeah, it learned all about cats. I'm a dog guy, I was kind of offended. But we have the Google Prediction API, which does a lot of that. It's these AI models in the cloud where you can train them with sets of data, ask for answers, and then it'll give you a prediction of what's there. It also does linear regression models and lots of other interesting things. And of course, at the top is Docs. I mentioned Docs on this slide because Docs can integrate with all these other tiers through this like Google Endpoints set of APIs that we expose out. So everything we expose, we have as a RESTful API. And Docs can actually program around these, whether it's in the spreadsheets or forms or other areas. It's actually pretty cool. So how does Google view the cloud? So this is, by the way, this last slide, this was how the industry views cloud. They think of it as this tiered model of infrastructure, platform, and software as a service. Google, we kind of think of it differently, though. We think of it as apps. There's a set of things that we built that you use. And then we have these other buckets of how we think about the cloud platform. We certainly think about how do you build your front-end stuff, like websites and apps, whether it's in your mobile phone or Android apps, whatever they are. We kind of have this part that we think about as the apps. We think about your data. Data is very important, and this is where privacy of your data is extremely important. We are one of the first cloud providers out there to have encryption at rest, so all data in Google Compute Engine is encrypted, and we're taking that same mean and value to the rest of our Google Cloud. So that basically means there's a key. We don't really have your key. You lose your key, you're hosed because you're not going to get your data back. But there's probably one engineer who's highly audited somewhere that can get the key. But it's very, very, very controlled. So we think about storing your data. We think about computation at scale. We're very interested in scientific workloads. And we've done all kinds of interesting things like genomics, video rendering, and so forth. There's been some really great articles that are written about our computational capabilities, and those are out there. And then, of course, analyzing your big data, which is a problem. If you have terabytes of data, actually, how do you analyze it? There's another interesting problem, which is I have terabytes of data. How do I get it into the Google Cloud? Turns out I don't really want to admit it. You can send us a disk. Not everybody's internet is like Google's internet. But once it's in the Google Cloud, it's extremely fast. Yes, but you can send us a disk and we will actually upload it into the cloud for you. So this is more of the Google model. We think about apps, computation, data, and analyzing the data. So what did we do to build cloud? So there are a bunch of principles and properties that we've really held to, which are security. And by security, I mean security and privacy. We are highly, highly audited. There's nothing that I can think of that can be touched in cloud that isn't audited. So if somebody has touched a piece of data, it's known who it was, when they did it, how long they touched it, for what purpose they did it, and we have a very tight set of audited controls. And you'll see more about audit processes and other things later in the year. We have strong auth models. So we chose this auth model called OAuth 2. It's a little complicated from the developer end, which is why we've uploaded to GitHub a bunch of code samples, like how to program the Google Cloud. So if you want to use Cloud SQL or Compute Engine or whatever else, we put a bunch of example apps out there. But there's some cool properties of OAuth 2, which is like revocable access. If you give somebody an access token, you can actually go in and just revoke access to that access token, which is something that's important. So, because once you've given somebody access to an app, you want to be able to revoke it at some point. You don't want them to have, they've got your key and they always have your key. That's a problem. OAuth 2 has other things like time limits. Like you may look at the data for the next 5 minutes, and after that you can't get it. And so you see things like that show up in our storage tier where we'll give you at least 5 minutes to pull the image, and after the 5 minutes you can't see it anymore. And so while there's some slight complexity for developers there's a lot of power that comes for security around that. Consistency was a second meme that fell. I'm actually very happy to see the blogs picking up on this, where they go out and they say things like, Google Compute Engine is the most consistently performing virtual machine in the cloud. Like if I'm getting 100 IOPS a second to disk now, I see it now, tomorrow, no matter how much seems to be running, the workload seems to run exactly the same time and time again. That is extremely hard to do, but something we value a lot is consistency. Open and flexible. We're giving all the examples out. In fact, all of our UI that I'm going to show you later, you can develop all of these UI yourself. This is something that we've held as a principle. We want people to build on cloud from all layers, whether it's the management orchestration layer all the way up. And then, yes, we have code. And I'm a security guy, so I try to use some leet speak on you there. Yeah. We has code. I tried to trick you. And then proven. So we actually do use all of these services today ourselves in production. Google is one of the few companies I've ever been at where we actually use all the things that you use. We don't use anything different. We use the same thing, which is very cool. So we prove the technology, and we won't ship it until it's ready. So I sometimes get the question, why the Google Cloud? Well, that sounds all great, Tony.